Howdy. Let's talk a bit about weather because I think it's safe to talk about weather. Everybody talks about weather all the time. So it might be a safe topic to talk about. What you are looking at here is a picture I took some time ago, and yeah, it's raining both directions. It's raining upwards and downwards, which is interesting because we are not very used to upwards rain or stuff like that. But I've witnessed this, and I think somewhere I might even have some video footage of that. But I got so much footage gathered in recent months that it's a bit hard to find specific things. But I gathered a few, which I'm going to show you after a small introduction into the topic of weather from a professional point of view. And let's just have a look at that, what they're talking about. So I found this paper because I know that the meteorological science basically is based on the chaos theory, which in my opinion is something not very reliable. Because if you think about the chaos theory, where everything can happen at any time, in any way, no one knows, you know, it doesn't seem to be very reliable. So, what does science do about that? It is they are taking mathematics and supercomputers because they think they can conquer the chaos with mathematics and supercomputers. That's why if you want to go to study meteorology, you have to be very good at mathematics. Because it's chaos. Chaos and Weather Prediction, January 2000 by Roberto Buizza. European Center for Medium Range Weather. Abstract introduction, the Lawrence, then we go to the introduction. A dynamical system shows a chaotic behavior if most orbits exhibit sensitive dependence. Okay. An orbit is characterized by sensitive dependence of most other orbits that pass close to it at some point do not remain close to it as time advances. All right. Yes, stuff is changing. And here we have some low pressure forecast for geopotential height of 1000 hectopascal. This field illustrates an atmospheric state close to the surface. Given by three forecasts started from very similar initial conditions, and the verifying analysis contour intervals is 5 meters. The atmosphere exhibits this behavior. Shows three different weather forecasts all started from very similar initial conditions. The differences among the three initial conditions were smaller than estimated analysis errors, and each of the three initial conditions could be considered as an equally probable estimate of the true initial state of the atmosphere. After 5 days of numerical integration, the three forecasts evolved into very different atmospheric situations. In particular, note the different positions of the cyclone forecasts in the Eastern Atlantic approaching United Kingdom. Figure A to C. The forecast indicated two areas of weak cyclonic circulation west and south of the British Isles. The second forecast positioned a more intense cyclone southwest of Cornwall, and the third forecast kept a cyclone in the open seas. Alright, if you want to read the whole paper, do it. I won't do it for you because I really want to share with you something. I have to, because otherwise I wouldn't be what I am. That's why I have to. You know, you have to be in order. And what was it the saying? Be the change you want to see. Yeah. So sometimes it's very hard being the change you want to see, because there's somewhere has to be the energy for doing this stuff. And recently, there wasn't. Now I feel maybe there is, so I try. Okay, we are now about chaos and weather prediction. So they are talking about weather is chaotic. That's why they need mathematics and all this kind of stuff. Supercomputers and so on. We go to the plate tectonic issues, the influence of electricity in rock-forming processes, and the coherent connection between science, mythology, and history of Finland. Paper part 2. Geology, an all-encompassing topic. So this is my paper, which got first in a way requested, and then I got told it's too thought-provoking. That's why it didn't make it into the journal. What? Anyway, that's me. And that's a sand dune. The author is standing in front of a dune. Conventional theory considers these kinds of mounds as glacial deposits, so-called moraines, but the author considers them as dunes, i.e. winds were creating these landscape features. Winds like no one alive today has ever experienced, but many ancient tales are telling us. Alright, this paper is a continuation of the first paper with the same title. And there is also part 3. Then we go down a little bit. Remember, we are talking about weather still. I talk about the Markland convection, an attempt to show how the depletion of elements in the Markland current and how they correlate with Earth's atmospheric layers. Note how oxygen and hydrogen are situated on the outer periphery. The closer to the core we come, the denser it gets. In the atmosphere we have water in gaseous form, but on the surface it is liquid, except it's frozen. To some depths, the water stays liquid, but even deeper it turns into a crystalline state, an actual mineral. Yeah, it's a crystal, it's not a liquid. I point out about Bargan currents and counter-rotation, magnetospheres, and there's I just wanted to show you a few pictures. You can read the whole stuff if you want to. There is a cloud. The Bursa cloud, which was quite likely a precursor earthquake phenomena. And of course, the surface conductivity anomaly here. And I found the surface conductivity anomaly because I was following, or I noticed the repetitive weather pattern. I was watching satellite pictures, and after some time of research, I found the surface conductivity anomaly. So, geology is an all-encompassing topic. I found something which is not very visible with bare eyes in the ground that has a huge influence on the weather here by watching the weather satellite pictures, and I found the surface conductivity anomaly, and you won't hear that the last time. The SCA. Anyway, Sapphire project. The anode from the Sapphire project is surrounded by several double layers. The picture tries to bring forward analogies of it compared to Earth's atmosphere and its layers. There are obviously striking similarities visible, but also the aspect of scalability has to taken into account, or is taken into account. Earth's atmospheric layers, troposphere and stuff like that, compared to the anode of the Sapphire project anode. Same principle, different gases, different energy flows and potentials and heat and everything is different. But it's all the same. Earth's atmosphere is kept in the place by the same principle because there is the current flowing through Earth that creates the layers. The same thing. And for those who have seen the Sapphire Project videos, sometimes there are just 3 layers, and sometimes we have, I don't know what they say, 7 or 11, or what's the maximum they got. Sometimes there's just 1. And sometimes there are just those sphericals on top of the ball. There isn't even like this plasma sheath around it. But anyway, hopefully they answer me once. Sapphire people, I like you. But we are still talking about weather, remember. Yeah, there's metal in the ground and other stuff. That's why the weather does what it does. There's a vortex-like structure also nearby. I don't know where exactly still, because the maps are not that accurate. These are self-made overlays. I made them by myself. For example, the one here, 3 maps on top of each other. And they all correlate amazingly well. In other words, it cannot be a coincidence. You could plot all those maps on top of each other and they will fit very nicely. Of course, we have to take into account that those maps aren't as accurate, probably. There might be some faults in the maps as well. Understandable. Yeah, greenstone stuff. Craters and lines, alignments, and separations of elements vitrified in stone. And yet another prime example of double layering. That's an almond stone, I guess. And this area here is the SFC, the Southern Finland Conductor. Yeah. And it is an arc. How funny. A comparison of the surface conductivity anomaly in Scandinavia and the polar cusps. The similarities between the imprint in Earth's crust and the polar cusps might not have a better explanation than that what is proposed in this paper. That is, the polar cusps, which are here is Earth, and it goes up. Maybe you have to go back out a bit. So that's The Birkeland current, no, I missed. Let's try it one last time. That's the polar cusp, and that's the polar cusp. That's the Birkeland current that goes through Earth. And let's imagine that this would be the sun. It goes through the sun. So it is a circuit. And somewhere down here, very at the very edge, it's not visible, it's too small, where we would have this black line, basically. Here on top, where it gets white, there we have the auroras, usually. And they're about 80 kilometers to about 100 kilometers above our heads, which is not far at all compared to where the polar cusps are. So in other words, if Earth's magnetic field is weakening, for whatever, if the nature of the input is changing or it's fluctuating in any way, the bubble here would get smaller, and eventually this would plunge onto the surface of Earth. And it would quite likely leave an imprint like we can see in Scandinavia in the ground with a surface conductivity anomaly. Yeah, and that's the the southern Finland conductor. Let's zoom in. No, it's not visible. SFC, anyway. So that's the imprint in Earth's crust. Some of it is visible with the craters, hence all the lakes in Finland. Copper mines and copper mountains that are even mentioned in the Kalevala. Yeah, there is a copper mountain. And the Outokumpu, like Kumpu means mountain or hill, is the only geological occurrence I could call a copper mountain, as far as I know, in the larger Karelian area, which is about this big at least. And here's the only copper mountain I know about. There are many other copper mines, but they are not mountains or not hills. Anyway. So guess what? What is your electricity flowing through into your house? It's copper wire. Yeah, there's some volcanic plasma phenomena and stuff like that. You can check them all out in this paper. Radiation's crazy, or is something very important missing? The thing about copper, sulfur, and the Kalevala. Like I mentioned, the copper mountain mentioned in the Kalevala. But there is also something else mentioned in the Kalevala. The world tree, the tree that keeps the heavens. Northwest, east. That's the surface conductivity anomaly. That's the Kalevala, the Oxford version. The word solo to topple. So at the third time he could fell the oak and shatter the world's sallow and bring down the 100-leaved. The base he thrust to the east. The top he lowered northwest. The foliage to the great south. The boughs halfway northward. To the east and northwest. East and northwest, as described in the big book of Kalevala. But anyway, we are still talking about weather. I just wanted to show you a few things as an introduction into what I'm gonna show you, because probably, maybe, hopefully you have seen all these things already. If not, I really recommend you to catch up. Yeah, there's a comparison about sulfur and stuff, the origin here in Finland. Volcanic origin, little or no evidence of volcanic activity in the last few thousand years. Yeah, there's no really volcanoes here in Finland. A great Moho depth, i.e. very low geothermal activity. Yeah, we have a very great Moho depth, about 80 kilometers at deepest. Yeah, the Moho is a conductivity anomaly layer within the Earth's crust. And it's very deep here, and usually where it's very shallow, you have geothermal activity on volcanic or volcanism as it is known to common man, that is usually associated only with hot water and hot lava, but we have to take into account the geothermal activity takes into account water from 0 degrees. It doesn't need to be hot in order to be geothermal activity. It has to be liquid, that's it. So every spring you find on every hill or mountain anywhere where you have water pouring out is part of geothermal activity and therefore volcanic activity. As are glaciers, are lava streams made of water. They are volcanic in nature. Every glacier carrying mountain is a volcano. If you have a spring where you have very nice water pouring out, you might expect that there might be fluctuations in the outflow of this spring. In other words, there could be times where you don't have any water coming out. Then you can have times where you have all of a sudden there is a lot of water coming out. And even much more that you could handle, so to say. And there could be more coming out than just water, maybe dirty water or even rocks. Let's just take the Biscuit Geyser as an example. Yeah, there has been rocks flying around stuff, you know? And there are many cold water geysers in the world which can do exactly the same thing. There might be coming rocks out of that hole one day. But anyway, let's try to stay to weather, and I don't care how long this video gets. Yeah, sulfur. Yeah, if we talk about weather, we have to take sulfur into account because I noticed that the sulfur content in the air has a very great influence on the weather. Usually it cools weather down. For whatever reason, I don't know. It somehow also seems to trigger precipitation. That might be because sulfur is this kind of material that seems to connect stuff. I don't know, it's very hard to explain, as I mentioned already in the Maragoni effect welding, electric arc welding paper, when they put a little bit more sulfur in there. The pool changes into a greater depth, and all these kind of things are happening just by adding a little bit of sulfur. So if we have sulfur in the atmosphere, it does something to the weather. Let's say like that. Usually it cools it down. It triggers rainfall and stuff like that. And the origin in many places are, for me, still very unknown. The Ohio Valley might be something where we have to take a look at closer once. If anyone knows why there's so much sulfur dioxide emissions originating from the Ohio Valley, tell me. If there are many copper melting operations and stuff like these, this might be a reason. But if there are not many, if there are just a few, and we still get these regular sulfur emissions from the Ohio Valley, the reason might be geological. In other words, we have to deal with telluric currents and stuff like that, because geology is electric in nature, as all of the things are. Anyway, sulfur is found in the solar wind. Sulfur is found on other planetary bodies and moons in our solar system. Sulfur is found on comets. sulfur depletion on Earth and other planetary bodies through electromagnetic forces, see surface conductivity anomaly. Close connection to copper and other metals, possible transmutation and electromagnetic separation of elements occurring during depletion event, expectable. Auroral precipitation would be the word for that. But anyway, let's go on to the weather because I just wanted to show you a few captures I made recently. Now we get the picture I wanted to. Because we have the surface conductivity anomaly once again. Hopefully you remember these words, the surface conductivity anomaly. And I have been pondering about these because we have to take into account basic electromagnetic laws as the right-hand rule and stuff like that. In this area, we have a region where we usually get high pressure systems and they spin this way. That's why I drew these directional arrows here that implicate the magnetic vortex direction. And of course, these are spinning the other way. And usually, or very often, we experience here high pressure, what is it? Yeah, high pressure systems here. So it's rather hot. Here, Eastern Finland is it's the hottest place in Finland that we have the record in heat. But also it's one of the coldest because it's a high pressure system area. And it's always the same place. It has even a Finnish name, it's Ikärisyskupoli, which in a way means the boiling top or dome. Yeah, because it's a magnetic vortex and we have to imagine that there would be a pillar. It's the magnetic pillar on which around the winds are spinning. And here we have another magnetic part or energy flow pillar, let's say like this. And because of the polarity of the ground, this tends to spin on the other side. And because one of them seems to be bigger and maybe stronger, it usually keeps the balance in order to say that the stronger wins. That's the balance. You know. So, recently, yeah, this is the reason for why I think this has very implications on modern weather or modern society in order to understand that things. And here's just one example of radar. When this is spinning this way and this is spinning that way, we get this feature here in the middle. It's very simple. And when we go northwards here we have a region where the blue and the red are meeting. And here somewhere is Oulu, the city. They have usually very heavy thunderstorms and a lot of rain and stuff like that. And this geological imprint is the reason for this. Why it's always there? Because it's in the ground. And I tried to take contact because they were talking about this. The worst scenario of all is severe frost and windless high pressure ridge that persists in the north, and Finland has not received an Olkiluoto 3 unit for commercial use, says Pia Ersch, director of the Energy Supply Department of the National Security Agency. Here is basically the start of the Southern Finland Conductor, SFC, a conductor that ends in a way here on the other side. It's about 400 kilometers long at its longest and about 50 kilometers wide at its widest. Then here you can see it in another Kursk magnetic anomaly. So that's the Kursk magnetic anomaly, which is very heavily relied or tied to the rest of that. That's basically all the same thing. Just these two maps would explain or are explaining so many weather occurrences here. Not only here, because these things are going on all over the place. And as I have been drawing just before with those pillars that we have, which are emerging basically from these centers on which around these things are spinning, which are ionic winds. These are all winds on Earth are ionic. And especially these where we have strong geological occurrences, they exhibit very strong ionic flows, so they just try to spin all the time in the same direction because this is nature works. And sometimes these directions of flows, of course, change direction because energy is flowing always both ways. Sometimes, or usually, the main flow has the same direction because just of the overall strength or the electromagnetic potential strength of the geological imprint compared to the electromagnetic potential within the air. Sometimes things change. And so was the case some time ago. As you can see here on the screen, it starts to spin in basically the wrong direction. That was interesting. Of course, I have been following that. I knew it seemed that something like this would occur. And it really happened. Let's see, do we have... Yeah, let's push it like that. Maybe that's better. So let's take a closer look at this. That's from below. And it's almost at the one of the centers that little low pressure system had. And here we can see rising up, punches through. And I also want you to notice how stationary these clouds basically are. They're just emerging there and staying there. And now let's just watch that and we go. I want to show you a few things. So now let's go to somewhere here. Here we can see that it starts to, there's some energy flow upwards and the clouds start to here it's very easily visible. Maybe I have to zoom out again. There's something going on. All of a sudden they are bulging up, and here on the right side there's something very interesting happening. There's all of a sudden there's a little vortex creating there. So we have to think that there's a connection established between the ground and the clouds. Let me back up a little bit. Here you can see the first action going on. And it's spinning. How else it could do? Yeah, that's a bit of a pity because we have this very nice sign in the middle of the screen. And as soon as it establishes a proper connection to the ground, it seems that it tries to do the same thing here, but here it seems to have more luck. And as soon as there's a proper connection established, and you can see for a brief moment a small vortex structure in the cloud, then it starts to rain and the equilibrium is established again. And you will notice we go on with the time lapse, then you can see that they disappear, the clouds disappear. And just watch here on the right side, I find that very interesting. Now it gets up. There's the connection. And immediately it starts to rain. You can see even the drops here. And we have still, it's still pointing downwards here, and there's another one. And here's a small one, and here's one. I call them tendrils, I don't know how to call them else. But they are like these kind of similar things, like from plasma balls you can see. So now let's back up this and you can watch that for yourself. Now we get the vortex. It punches through and we get the rain. Now the equilibrium, now it rains a bit. The whole thing just loses in a way its structure because it gets discharged. You need energy in order to maintain structure. So when something gets discharged, it loses also partially its structure. And obviously you can see it's over now. There has been this discharge event, there has been energy coming from below, as you saw. The clouds, they were bulging upwards. Here you can see in a way it's coming from beneath the energy. And also here it's very easy visible. There's energy rising from below and the clouds are just moving upwards. Then we get the rain. The structure in a way disappears. Or it transforms into rather straight lines because rain is vertical. Sometimes. So, this was the first thing I wanted to show you. And just as a quick reminder about the chaos and weather, before we go to something else still. These are noctilucent clouds from recently. And I wanted to show you something where you might think that, yeah, this doesn't look really like chaos. Because we have many lines, many repetitive patterns. There's no chaos, there's just very complex order. You know. These aren't random occurrences, they all occur for a reason. There's no chaos anywhere. Chaos doesn't exist. So now, before we go to the next or probably last video, I want to show you about weather clouds that are totally random things according to meteorology. But in my opinion, they're something completely different. Clouds are plasma. They're always plasma. And I showed you now energy exchange between the ground and the heavens and how they discharge and stuff like that. From above and below. Now I just wanted to show you still one more thing in order to prove or make my point about not only that weather is entirely an electromagnetic occurrence or mechanism, but also that clouds are plasma. They have to be if they are part of the electric weather. It cannot be anything else. Let's just have a listen to what he explains at the beginning. And here on the screen you can see already what's the thing about. Let's have a look and listen to him.
This is a plasma toroid generator, a desktop device that generates a ring of plasma, the same material that's in the sun, at your desk. In the last video, I explained how it works, but it turned out I was wrong. And also I've done experiments with this device since then, and this is my second generation of the device, and it's lighter, runs cooler, and it's more robust. Here, look. And also, there is a giveaway at the end, sponsored by Engineered Labs. I'm going to be giving away samples of potassium and platinum. So, enjoy the video. Okay, so I should probably address the elephant in the room, and that's that the plasma toroid is not a new discovery. I thought it was when I discovered Magic Plasma's device last summer, but it turns out, according to high voltage YouTuber and researcher Viduli, this phenomena was discovered back in 1884 by a German physicist named Johann Wilhelm Hittorf. I practiced that, and I think I did okay. Anyway, so Hittorf experimented with evacuated glass vessels charged with high voltage, and he discovered the plasma toroid using a pulsed excitation. Wait, I should probably explain how this correctly works, starting with the center of the coil of wire. This is the coil that I was talking about. This is the oscillator circuit that switches current back and forth through these coils. And since there's current changing, that means there's a magnetic field around these coils. And that magnetic field is also changing in size. That's what I mean by changing. I mean, the strength of the magnetic field is constantly changing. And since that magnetic field is constantly changing, it's going to create another electric field, one of its own. And the shape of that electric field is going to be in a ring. Sound familiar? Heck yeah. I should have known, but I didn't. I thought it was the magnetic field last video, and that is just wrong. When the circular electric field is strong enough, it'll start to rip field created around the wire like this. This is the magnetic field. It's curling like this, and the electricity is going this way, right? And when you change the electric current, the magnetic field will also change with it. This is just a property of electricity and magnetism. And one more thing that is important to know is that when you wrap a wire into the shape of a coil like this, that adds up the magnetic field around each turn of the wire, making a stronger magnetic field down the center of the coil of wire. This is the coil that I was talking about. This is the...
Alright, you get the idea. And let's see how it looks actually.
Play soccer. You may be wondering what the squealing sound is, and I think it's the plasma vibrating against the glass, and then the glass vibrates too. But I'd love to hear your guys' thoughts in the comments. Now that we know that the plasma toroid has thermal characteristics like convection.
Alright, now we have seen that there is something like a plasma toroid. And let me show you something I captured recently. Since I'm not a computer person, I still have my own sketchy ways in order to show you stuff. Here was basically one of the reasons why I decided to make that time-lapse shot, because once again we have totally random repetitive structures again in the sky. Yeah, there is no chaos, clouds or plasma. The more energy is flowing, the more structure you get. So now let's just have a look at that first. Not only can you see that the clouds are moving in different directions and how they maintain their structure, and also how they can appear out of nothing. Spooky action over distance, eh? But now I have to search for it once again. Because I captured something very interesting. Here we can see on the right side there's some action going on. And this is, I think, where I saw that other. Yeah, you can see how the energy is spreading out. Now let's just have a look at that. Enjoy a moment of Zen. So now we have to go down here. And we can see already there are these different peaks or tendrils that are reaching out of the cloud. And this cloud here on the right side is rather fussy, so to say, and they are round. And I don't know how to explain this, but there might be the opposite of each other in a way, because they are shaped differently. And that might be the reason for why they are attracted to each other. It's a bit hard to explain. But now, as we go on, I really recommend you to watch this side, because there's action going on. We are going forward now. There's another one emerging, see that? This one. Let's go back and we go forward. There's emerging. And we can also see that how the energy here is going also in both ways. There is movement going on in both directions. Yeah, of course, it's cloud 3D. It can move in all directions at the same time, but you know, it might be swirling. It might be spinning after all. And it really does look like it would spin. Now we have to lift up a bit. Because here, I think, it's about here where you can see something emerging out of this lower cloud. No, it's actually there. It's in the space between. It's here. Here we have something coming, and here is something coming, but look at this area here. Out of the blue, once again. And here is already something making, see, it seems that something is making a connection, and this might be emerging from here. So there seems to be a connection going on here between the two. And this might be also related to what's emerging from here. This thing. And then, all of a sudden we have this kind of a darker cloud. Okay? It seems to be darker, as we have here on the right side too. I don't know what's going on with those. Is it just shadow? Maybe. Maybe not. I don't know. It's very interesting. Now let's just go on, because that was very interesting. First, we have this small white cloud emerging out of nothing. And from the other side, there's another one coming. And then it turns black. It lifts his head, then it turns black underneath, and there's something shooting out of that cloud. Look at that. And this might be the thing it's connecting to. So there's a connection going on. It's shooting out there. And then whole hell breaks loose. No, not really. Yeah, this is how plasma forms in the sky. We have this cloud here basically in the middle of the screen that tries to establish a connection, and then it finally does. But they never really merge together. But they have an electrical discharge or information exchange between each other. And there's a vortex here. There's yet a small vortex forming here. But if you think that's amazing, let's zoom out a little bit. Because the whole thing is much more amazing than you ever thought. Yeah, maybe not, but anyway. Now let's go to the same place where we are seeing that connection getting established. Yeah. So now here, remember just what we saw before, but we have to zoom out a little bit. Because you can see how this energy goes through or goes on or further within the cloud, and we can see a plasma tube emerging within the clouds. Now keep your eyes on that thing here, and then follow somewhat the path of my very sketchy line I just drew there. It might seem already to establish something here. I'm not too sure about that. Now we are getting the connection. And there is something going on here. Maybe still a bit further. See that? Connection from here goes somewhere to the whole cloud. It's already visible here. Yeah, that's a plasma tube here in the clouds. That is there only for a brief moment, and then we experience in a way the same thing as we have seen earlier with the rain that discharged after it established the connection. And maybe, I don't know, that's funny or interesting at least. We have two, like often Birkeland currents are described as two. So now once again, here is rising up and it established the connection which goes through the whole cloud, and we can see the whole thing. Now we can see the connection established here that goes all the way down there. And it might ground itself, maybe invisible to our eyes. Yeah, then it dissipates. Yeah, let's look at this one I just noticed here in the middle of the screen, just emerging out of nowhere. Here. We are going backwards, now we are going forwards, just in order for you to know. And they are very high up, I guess, these clouds. Yeah, and again, totally random, equal spacing occurrences. This has nothing to do with chaos or whatsoever. This is the complete opposite of chaos. Yeah, there's a nice cloud here. This one also too emerges out of nothing. No, it's emerging out of another cloud, really? So this cannot be shadow. Yes, I have to admit that I'm very baffled right now. Because the sun is on this side. So the white cloud would be in the shadow already. How is that possible? We have a dark cloud emerging out of the white cloud, really? So that's rising up to a certain height. And then on this side, something white is coming out, and on this side, something black. Let's say black. That dissipates. Yeah, that's something to think about. But anyway, I leave it here. Weather always interesting. Weather is always interesting. We are weather. Thanks.